Hello students, I am Praveen Singh from the Mechanical Engineering Department. I welcome you all to today's video lecture. Student, today we are going to study a very important topic, mechanical properties of engineering material. In engineering, selecting the right material is extremely important because every material behave differently under different load and condition. So, understanding these properties help us in design, manufacturing and analysis. What are the mechanical properties? Mechanical properties describe how a material behave when force are applied. These properties help us understand whether a material will deform, bend, crack or break under the load. Engineer use this knowledge to select the most suitable material for each application. Before learning individual properties, we must understand the basic concept of stress and strain. Stress is the internal resistance developed inside a material when the external force is applied. And formula is stress equal to force upon cross sectional area. Strain Strain is the deformation produced in a material under per unit length, and formula is strain equal to change in length upon original length. As the load increases, stress and strain also increases. Strength Strength is the ability of material to withstand an applied load without failure. The maximum stress a material can bear before breaking is called ultimate strength. Elasticity Elasticity is the property of a material by which its return to its original shape after the load is removed. This behavior is reversible. Material like steel and rubber show good elasticity. Next property is plasticity. Plasticity is the ability of material to undergo permanent deformation without breaking. Plastic deformation begin only after the elastic limit is crossed. This property increased with temperature. This is a stress strain curve. Show elasticity and plasticity for material. Stress strain curve. The stress strain curve show both elastic and plastic behavior of material. Engineers use this curve to understand material behavior and to design safe components. Stiffness. Stiffness is the resistance of a material to elastic deformation. A material that deform a very little load is said to be stiff. For example, steel beam is stiffer than an aluminum beam. Ductility. Ductility is the important property of the material. Ductility is the property by which a material can be drawn into thin wire. For example, mild steel is a highly ductile material. Percentage elongation is commonly used in measure ductility. Malleability. Malleability is the ability of material to be hammered or rolled into thin sheet without cracking. Lead is a good example of malleability material. Comparison between ductility and malleability. Ductility is related to tensile load, the ability to form thin wire. Malleability is related to compressive load, the ability to form sheet. Both properties are different from each other. Hardness. Hardness is the ability of material to resist scratching, indentation, abrasion, or cutting. Common hardness testing method used: Brinell test, Rockwell test. Brittleness. Brittleness is the property by which a material break with very little deformation. For example, glass and cast iron are common example of brittle material. Next property is creep. Creep is the slow and time dependent deformation of material under constant stress. It occurs even at stress below the elastic limit, especially at high temperature. For example, boiler, turbine, and engines face creep issues. Fatigue. Fatigue is the failure of a material due to repeated or fluctuating stresses over time, even if the stresses are low. Thin cracks start forming and gradually grow until a material fails. The example is turbine blades and aircraft component commonly experience fatigue. Thank you, students.